The major Autoflight components include the auto throttle, the mode control panel, or MCP, 3 autopilots, the flight management system, 2 flight directors, and 3 flight control computers, or FCCs. The flight control computers are the heart of the Autoflight system. Crew inputs to the FCCs are made through the mode control panel located on the glare shield. Inputs can also be made with the flight management system, which will be covered in the FMS lesson. The FCCs also operate in conjunction with a variety of other systems. The data is processed by the FCCs and sent out as control signals to autopilots. Data is also sent from the FCCs to the flight director's command bars, which display pitch and roll information. Normal in-flight operations can be described as either automated or non-automated. Non-automated flight is defined as hand flying without use of the flight directors. Automated flight consists of 4 levels. During normal operations, all 4 automation levels require use of the mode control panel, FCCs, and flight directors. In Level 1, the aircraft is flown manually using the control wheel with the aid of the flight directors. A flight director takeoff is an example of Level 1 automation. In Level 2, aircraft maneuvering is accomplished with an autopilot in control wheel steering. For example, during the en route climb after takeoff. Level 3 requires an autopilot in command, such as during cruise. And finally, Level 4 automation incorporates the flight management system, for example, when cleared direct to a waypoint. In summary, Automation Level 1 is associated with hand flying while referencing the flight director. Level 2 with the CWS switch. Level 3 with the command switch. And Level 4 with the FMS. Let's now discuss the flight directors. The flight directors can monitor any one of 3 flight control computers, left, center, or right. The flight control computer to be monitored can be selected from each pilot's instrument panel. These panels are located on the outer portion of each side of the instrument panel. Normally, the left FCC is selected for the captain's flight director, and the right FCC is selected for the first officer's flight director. Both pilots, however, may select the same FCC at the same time. Each flight director can also monitor the center FCC. Each flight director is controlled by an on-off switch located on the mode control panel. Moving the switch to on connects the associated flight director to the selected FCC. This is indicated by command bars appearing on the ADI, accompanied by green FD letters. In addition, when the flight directors are engaged on the ground, they automatically engage in the takeoff mode, which will be discussed later. During the remainder of the lesson, you will perform Autoflight tasks by clicking on the on-screen MCP. There will be no audio. Instead, instructions will be displayed above the mode control panel. The captain's ADI will be displayed to show various mode enunciations. One wrong input will cause help to appear with locator arrows. If help is required, click on the help icon. When finished with the task, click on the right arrow. Let's now look at the autopilot. There are 3 autopilots designated left, center, and right. Each autopilot is controlled by its respective FCC. The link between the FCC and its associated autopilot cannot be changed. Consequently, an FCC failure also causes the loss of its associated autopilot. The FCC sends control signals to independent servo actuators that hydraulically position the flight controls. Normally, only one autopilot can be engaged at a time to provide pitch and roll control during climb, cruise, and descent. During the landing phase, multiple autopilots are engaged simultaneously for ILS approaches and automatic landings. During an automatic landing and rollout, rudder control and nose wheel steering are added to maintain runway alignment and centerline tracking. Switches for each autopilot, labeled Command and Control Wheel Steering, select the respective operating mode for engagement. Pressing either switch illuminates a light bar in the switch, indicating that an engagement request has been sent to the associated flight control computer. If the FCC engages the requested mode, it will be displayed on both ADIs in green text. Once the autopilot is engaged, one operating mode can be replaced by the other by pressing the associated engagement switch. When control wheel steering is engaged, pitch and roll attitudes are established manually with the control wheel. When control wheel pressure is released, the autopilot will hold existing aircraft attitude. If control wheel pressure is released with less than 3 degrees of bank, the autopilot will roll the aircraft wings level and hold the existing heading. Command can be engaged with the flight directors on or off. If command is engaged and both flight directors are off, the autopilot holds the existing heading and vertical speed. If command is engaged with the flight director switched on, the autopilot will fly the engaged flight director modes indicated on the ADIs. To engage a different autopilot, the operating autopilot must first be manually disengaged. There are 2 ways of manually disengaging an autopilot. The first method uses the control wheel autopilot disconnect switch, which is normally pressed twice. The first press disengages the autopilot, which is accompanied by an autopilot disconnect light and warning alerts. The second press extinguishes the disconnect light and warnings. Autopilot disengagement can also be accomplished by pushing down a disengage bar located beneath the autopilot switches. When pushed down, the bar displays an orange stripe to indicate the disengage position, accompanied by visual and oral warnings. The bar must be pushed up into the original position before any autopilot can be re-engaged. Automatic disengagement occurs when an autopilot can no longer safely fly the aircraft, accompanied by the visual and oral warnings. An autopilot may experience minor malfunctions that do not affect safety. In that event, autopilot operation will continue, but with slightly degraded operation. Degraded operation is signaled by an autopilot discrete light, accompanied by the associated ICAS caution alert. Now let's move on to autothrottles. The autothrottle system provides automatic thrust control from the start of takeoff roll through an automatic landing or go-around. The autothrottle can be operated with or without the autopilot and flight directors engaged. The autothrottle system includes a portion of the mode control panel, a thrust mode select panel, and a thrust management computer. The thrust management computer commands a servo motor that moves both throttles at the same time. Controls and indicators are located on the glare shield, center instrument panel, and throttles, which contain auto throttle disconnect switches and a go-around switch. Auto throttle engagement is initiated with a 2-position auto throttle arm switch. Selecting arm arms the auto throttle for engagement, powers the servo motor. Selecting off disconnects the auto throttle system and prevents engagement. Four mode selector switches and the go-around switch determine the operating auto throttle mode. The EPR and speed switches affect only the auto throttle. The go-around switch as well as the VNAV and flight level change switches affect the auto throttle, autopilot, and flight directors. The VNAV function will be discussed in the FMS lesson. There are 5 auto throttle modes and 1 sub-mode. Pressing one of the selector switches engages the auto throttle if armed. Auto throttle engagement is indicated on each ADI by green AT text plus green text for the engaged mode. When a mode is first engaged, the text is enclosed in a green box for 10 seconds to attract attention. For lesson purposes, the on-screen ADI will display the green box for a much shorter time.